Howdy. So this is my code for my contribution to my group's beach cleanup squad, the Sand Sifter. My computer starts to get really slow when trying to use more than one Arduino, so this is a restricted version of what the full robot would look like for example's sake. It features two gear motors, here and here, one servo motor up here, an ultrasonic distance sensor down here, and a photoresistor here in the middle. I also have an IR sensor installed for example's sake, which the robot would use to receive signals from our overdrone robot to override all the code it's running through on its own. The code itself has around 240 lines of code. The first portion sets up all the variables for every motor in the robot, and some variables used within the code later on. Within the void setup block, I set up each of the pins, the serial.begin, and attach the servo and call it shoulder hinge. At the start of the program's loop block, I begin with setting up the distance sensor. It's constantly running, checking for any obstacles. After that, I would insert a block of code here for receiving a signal from the overdrone to override any of the four variables mentioned here. The light variable is constantly being updated with information from the photoresistor. These next few blocks check the level of light. The display monitor is updated when the amount of light is changed to be below or above the defined light threshold. So you can see here. I'm actually going to make the robot stop turning here. Cool. So darkness, bright, darkness, bright. During the daytime, I have a counter set up so that we don't flood the serial monitor. It calls the move forward function set up later to move the gear motors, and therefore the robot, forward, unless it's interrupted by a different function. Then there's a function for obstacle detection. If the ultrasonic sensor detects an obstacle within the defined parameters, it will turn left and allow the robot to move forward again. So right now, this gear is moving forward and this gear is moving forward. But when we come within 60 inches of it, it stops and then it starts to turn left. This moves forward and this moves back. And it will continue to do this until the obstacle has been removed. Great. The last function in the loop block allows the robot to rotate its hinges after 5 minutes so that it lifts its arms over its back, emptying the sifter into a receptacle on its back. Finally, I have some functions that several other functions can call in order to make the code a little cleaner. The last function down here is what I would include if the simulated environment allowed me to add a second servo motor without causing it to lag severely. It would shake the sifter at the ends of its arms to allow sand to pass through its sieve. Thank you.